Before we talk about any design pattern, it's important to look at how we would accomplish the same task when we don't use one. This helps us understand why it's important to use that pattern and any benefits it might give us. For example, here I have a really simple array of integers and a for loop that goes through and prints out each one. As we go through this loop, our value for I increments by 1 until we reach the end of the loop. Now for most programming scenarios, that for loop works perfectly fine, but there are some limitations to consider. For example, what if you want to have multiple things traversing over the same array? Or if you want to go over only specific things, such as only traversing over odd numbers? Or what if you want to remove items from the collection that you're currently traversing? Those are all limitations that the Iterator Design Pattern addresses and solves. This design pattern has two key parts: the iterable and the iterator. The iterable is just going to be whatever you're traversing over. It could be an array, a collection, a grid, or even a custom object that you wrote yourself. Now the iterator is the bulk of this design pattern, and that is what allows you to traverse over the iterable. Now this is really important, but the iterator and the iterable are both separate objects. That's really important because that means the iterator can have its own fields and methods unique to itself. Here's what that looks like. The iterable itself is pretty simple. It's just going to be a collection of data, but it might have a method that creates an iterator for that collection. The iterator, on the other hand, has a couple of more different things. Most importantly, it contains a reference to the iterable. This is very important. It does not contain the iterable itself or even a copy of that, only a reference to the original object, and we'll show you why this is so important later. It also has a private variable that keeps track of its current position inside the iterable. It's similar to how we used I to keep track of our position inside a for loop. It has a next method that returns both the next value in the iterable and increments the current position of the iterator. It also has a hasNext method, and this returns a boolean of whether or not another value exists inside the iterable. Okay, so here we have a couple of things. We have a list of numbers, which acts as our iterable, a console showing us our program output, and then the iterator itself. Here it's called listIterator, and it has a couple of methods inside of it, and it has that reference to the array. This points towards the numbers list. It does not contain it, just points towards it. Now in this example, I keep track of my current position using a variable called nextIndex. You could use currentIndex, but I find it a little easier to work like this, and this example is going to work with nextIndex. Now, like we mentioned before, every time I say listIterator.next, two things happen. First of all, I return the value that my iterator is currently on. In this case, that would be 2, since my index is 0. Next, I increment my index by 1 and move my pointer to the next position. Let's say I used next a couple more times on my iterator until my next index value is 7. 7 is outside the range of my iterable, and if I used hasNext now, that would return false because there are no more values that my iterator can access. Another cool thing about iterators is that they can also remove values inside whatever they're traversing over. However, they can't just remove any old value. They can only remove the value that was last returned when next was called. This is what that looks like. So here I have an iterable and an iterator. On my iterator, I call iterator.next, and that gives me 3. So once that value is returned, my current position is incremented by 1. Then when I called iterator.remove, it removes 3. And this is what the iterable looks like after that change has been made to it. This is why it's important to pass the actual reference to the iterable and not a copy of that iterable. Because if you want to make changes to whatever you're traversing over, you can't do that with just a copy. You have to have the original thing to actually make changes to it. Speaking of things you can't do, let's go back to our for loop example. Here we have a really simple for loop that basically removes every element inside this array list that has a value less than 0. If you did this, it would throw an exception because you cannot modify elements in a list you're traversing over, which is another reason why we use iterators. Another cool thing about iterators is that you don't have to have one iterator for one iterable. You can have multiple iterators all watching one iterable. And since all of these iterators only have a reference to this collection and not an actual copy of it, whenever values inside this iterable change, each iterator doesn't have to do anything special. They just have these updated values. And another cool thing is that each of these iterators can have its own type to it, so you can have different iterators with different conditions behind them. Let's look at an example that has two iterators, one that's normal and one that only goes through odd numbers in my array. Notice how whenever I call next, odd iterator only skips to odd numbers, whereas number goes through every number. And this design pattern doesn't even have to apply just to one-dimensional things. You can have a two-dimensional object, such as a grid, and then have an iterator traverse over this with maybe like ups and downs and lefts and rights. Here we have a little slime object that can move down and move right throughout this grid. Alright, so in conclusion, iterators allow you to encapsulate traversals in a different object. They allow you to modify whatever you're traversing as well. They can have special conditions, like the odd number one we saw before, and they can apply to multi-dimensional objects like that grid we saw. Thank you for watching.